Hello everybody. Today in our math class we are going to be focusing on logic. So let's start with this logic problem. So how we use this is that if we know something is true, like we know Frank is 8, we're going to put a plus there, and we're going to put minuses in all the other places, because if Frank is 8, Emma can't be 8, Jason can't be 8, Bruce can't be 8. And if Frank is 8, he can't be 9, he can't be 10, 11. So false, 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 false. Which makes it really easy to sort of, narrow things down. So let's start. We can already kind of guess what the problem is going to be based on how this is set up. And that Frank, Emma, Jason, and Bruce are 8, 9, 10, and 11 years old. So we're going to get 2 clues, and we're going to try and figure out how old everybody is. So our clues, let's start for the first one, is that Jason is older than Bruce and younger than Frank. This all by itself tells us a lot of important information, actually something really key that helps us do something really easily. So something that we have to think about to know about these kinds of things is that it's easier to tell what's false than what's true right at the get-go. Unless a clue gives you a true fact right from the beginning, you can't put it true. And actually with when thinking about logical things, knowing what doesn't work is sometimes easier. If you know things that are false, sometimes it's more helpful, but sometimes if you know truths, it can also be more beneficial. But falses can generally tend to be more generic. So you can usually use that to problem solve and find a lot of things that aren't true and help you narrow things down, which is what we're going to do right now. So again, Jason is older than Bruce and younger than Frank. What this tells us is that if Jason is older than Bruce, Jason cannot be 8. Because if Jason is 8, he cannot be older than anybody, because 8 is the youngest age. So we know Jason's not 8. And if he's younger than Frank, we know that Jason cannot be 11. Because if Jason is 11, everyone else is younger than him. He can't be younger than anybody. So right off the bat, we know these 2 things. Those things are false. Now, if you read the second clue, it actually uses similar language. Emma is younger than Jason and older than Bruce. Right now, who they're younger and older from doesn't really matter. For now, we know Emma is younger than somebody and older than somebody, which again means that Emma cannot be 8, because if she's 8, she's the youngest, she can't be older than anybody. And Emma can't be 11, because if she's the oldest, then she can't be younger than anybody. So again, we can cross that right off. Now, this is when we start caring about the names. Emma is younger than Jason. And Emma and Jason can only be 9 or 10 years old, which means that Emma is 9 and Jason is 10. Jason's older than her. So we figured that out. And then now we're going to put X's everywhere else, because Frank and Bruce cannot be 9 or 10. Now, this number 1 is where we can figure out the rest of this. Jason is older than Bruce. Now, Jason's 10. And because Emma's 9, we know that Bruce is 8. And because Jason is younger than Frank, we know Frank has to be the oldest. Plus, that's the only one that's left. So we know that Frank is the oldest. So this is a very useful way of collecting data in a way and recording it in a way that helps you figure things out, so you don't have to keep all of these in your brain. So if you have any questions, let me know. And if you want me to find you any more problem-solving questions like this, I'm more than happy to send you a couple of links, because this is actually, I find it very enjoyable. I find it fun. So thank you for participating in today's class. And again, if you have any questions or want any more resources, feel free to ask me.